Welcome to tutorial number 14. It's about CrusherX's modulation functionalities. Every vapor parameter can have its own individual modulation with different adjustments of modulation depth, modulation frequency, phase, modulation modes, and so on. Additionally to these individual modulations, there is the so-called cloud modulation. There is only one cloud modulation. It is the same for all parameters. Only the amount of this additional modulation can be different with each parameter and its phase. The cloud modulation simply adds to the individual modulation of each parameter. I'll use the parameter speed in this video because it shows the modulations most easily and most clearly. At first, the individual modulation of the speed parameter. Then I add a cloud modulation and adjust an amount. Or what about a different frequency of the cloud modulation? You will have noticed that CrusherX always jumps to the delay parameter when you change the cloud modulation, not with the amount of modulations. I find that behavior a little inconvenient. But if you take care and jump back to the wanted parameter, it's okay. The maximum range of offset of a parameter is given by the software itself. There is no way to extend this range using whatever combination of modulations. Adjusting the speed's offset at 5 and modulating it by a sine wave moves down the frequency with the negative half of the sine wave, but doesn't move it up with the positive half wave. Apart from that, the modulations sine, triangle, sawUp, sawDown, random and random line modulate the parameter around the adjusted offset, meaning the adjusted offset is in the middle of the range of the modulations. Be always aware of that, especially with the modulation modes sawUp and sawDown. You inadvertently might expect the modulation to go up or down from the adjusted offset. The modulation modes sine, triangle, sawDown, sawUp, and rectangle are self-explanatory. The mode random doesn't need an explanation either, but random line is interesting. Like in random mode, the mode random line makes CrusherX determine values randomly. But CrusherX does not jump from random value to random value then, but morphs between the randomly set values. With random, the frequency of the modulation is quite meaningless, whereas it influences the result remarkably with random line. The 4 PM field modulation modes refer to the physical model grid called Physical Model XY field. There will be a separate video about the PM field. A short demonstration shall be sufficient for now. XUp PM field means that the depth of the modulation increases the more the blue ball moves to the right. XDown PM field means the opposite. YUp PM field means that the depth of the modulation increases the higher the blue ball moves in the PM field, and YDown PM field means the opposite. The modes OFF-down 0, OFF 50% and OFF-up 100% are a little special. None of these 3 modes modulates at all, but adds a fixed amount to the adjusted offset or just does nothing. Let me at first explain how to calculate this fixed amount before I tell you the advantage of having such non-modulating modulation modes. OFF-down 0% at first. The output value follows this formula. Please notice the modulus symbols. We are talking about absolute values here. FREQ of F origin means the original frequency being fed into CrusherX. Example. I switch CrusherX off and adjust my oscillator at exactly 250 Hz. I switch CrusherX on again, choose an offset of 2 and adjust depth at 3. The resulting frequency is 250 times 2 minus 250 times 3 makes minus 250 Hz. Modulus minus 250 is 250, and indeed, the spectrometer shows 250 Hz. The next mode is called OFF 50%. As long as the process slider is in middle position in linear mode, there is no influence at all. But changing the process to logarithmic or exponential processing changes the game totally. Here are 2 corresponding formulas. OFF up 100% at least. As with OFF down 0, there is no influence of the log and lin and exponential slider. The formula reads as shown. Don't forget what I said at the beginning. It is not possible to extend the maximum range of a parameter by modulating it, so sometimes the result may be different from your calculations using the shown formula just because you have reached the maximum value of a parameter. But what about the other parameters? The parameter speed has an external value to refer to, the frequency of the incoming sound, and the depth slider is a factor. What about, for example, birth? Well, delay, length and birth as parameters of time react identically. Let me demonstrate birth. With OFF-down 0% as modulation mode, there is no effect at all. Neither with a linear processing, nor with a logarithmic one, nor with an exponential one. With OFF 50%, 50% of the adjusted depth adds to the offset in linear processing. In exponential processing, nearly nothing is added to the offset, and in logarithmic processing, nearly the whole amount, nearly 100%, of the adjusted depth is added to the offset. With OFF-up 100%, the whole amount of depth is added to the offset. The processing mode linear, logarithmic or exponential doesn't matter. parameter sweep reacts similar to the before discussed parameter speed. The shown formulas are the shown formula are valid even with sweep. The only difference is the fact that with sweep we talk about a frequency range, meaning the formula gives you the borders of the range the grain's frequency sweeps over. XCRUSH, overdrive, filter frequency and filter Q show the same behavior as delay, length and birth. Off down 0% doesn't have any effect. Off 50% adds half of the amount of depth to the offset in linear processing. Nearly 100% of the depth in logarithmic processing and nearly nothing in exponential processing. And OffUp 100% always adds the whole adjusted amount of depth to the offset. The processing mode doesn't matter. The reaction of the parameter volume is different from the other parameters. Please look at the upper left corner where the DAW shows the exact amount of output volume when I move the mouse cursor over the dB meter. With the modulation mode off down 0%, the volume decreases by the shown amount. The kind of processing, linear, algorithmic or exponential, doesn't change anything. The mode off 50% doesn't change the input volume at all if in linear processing mode, but increases the volume when in logarithmic mode and decreases it in exponential mode. In logarithmic mode, the volume is increased exactly by the amount the depth slider shows when the process slider is completely turned to logarithmic. And in exponential mode, the volume decreases exactly by the depth slider's amount when the process slider is turned completely to the right, to exponential. With the modulation mode off up 100%, the volume increases by the amount the depth slider shows. The processing mode doesn't have any influence. The parameter PANORAMA isn't changed at all by the depth slider in the modulation mode off down 0%. For the following experiments I use only one generator. Please notice the two different colors of the graph in the signal analyzer's window. Blue shows the left stereo channel and green the right one. With OffUp 100%, the type of processing, linear, logarithmic or exponential, doesn't matter. The depth value decides where the output in the stereo spectrum is placed. Let me demonstrate three different offset settings. First, no offset at all. With increasing depth from 0 to 50%, the output changes from left at 0% to left and right at 50%. Increasing the depth even more, above 50%, the output changes completely to the right stereo channel. Second offset is 50%. Increasing depth from 0 to 50% changes the output from left and right to right only. Increasing further above 50% doesn't change anything. Third, offset is 25%. Increasing depth from 0 to 50% changes the output from 100% left plus 25% right over left and right equally at 25% to 100% right plus 25% left. Increasing depth further makes the left channel vanish completely. The modulation mode of 50% brings absolutely the same results with logarithmic processing, no changes at all with exponential processing, and halfway the changes of up 100% with linear processing. Wow, that's all about these three special non-modulating modulation modes. Before I answer the question, and what are these modes good for, I must talk about the phase slider. I switch back to the speed parameter and activate two generators again. The phase function brings the modulation cycle, here a sine wave, of both generators out of phase. When I increase the numbers of generators and decrease phase to less than 0.5, that's important, I get as many different modulation phases as there are generators. And now the long-expected answer. Because of the three discussed off modulation modes, I can adjust a parameter at a fixed value, but nevertheless use the phase function of the modulation panel. And with the automation function of your DAW or with any other MIDI source, you can change the phase of the modulation without changing anything else, especially without changing the offset between the modulators. The 6 MIDI modulation modes are quite self-explanatory. Don't forget to switch a MIDI mode on before you can use these modes. Well, the cloud modulation. The cloud modulation is just a second modulation source which adds to the modulations we have been talking about so far. But the right side of the cloud modulation panel, containing depth, modulation frequency, modulation mode, processing mode, and phase, is valid for all vapor parameters. The adjustments you make here cause on all and every vapor parameter. You cannot adjust these things for each parameter, speed, delay, birth, and so on, individually, like we did before. And there is something inconvenient. We told about it already. Always, when you change one of these common parameters, CrusherX jumps to the vapor parameter delay. So take care that you are really adjusting the parameter you want to. On the other hand, there is something about the cloud modulation which you can adjust individually. The left side of the cloud modulation panel containing the amount of cloud modulation and, again, a phase slider. There are only two things left to explain: the relation of the two phase sliders of the cloud modulation and the relation of cloud amount and depth. Phase at first. The phase shift is the difference between both sliders, not considering the minus or plus. In other words, there is a modulus formula again. Let me demonstrate that. And at last, cloud amount and cloud modulation depth. Well, the values simply multiply. Thank you for watching. If you want to support my work, please subscribe, like and share the video. Have a good time. Rolf.